Satellites. If you're over 40, the word alone may conjure up images of espionage or science fiction or future technology. But satellites have been around for a long time, and satellites may perhaps be the greatest tool ever invented. When you can position yourself 23,000 miles above the surface of the Earth and essentially lock into Earth's orbit, you can do all sorts of things that you can't do from the ground. Think of a satellite as a floating platform or laboratory, hovering high above us. So what do satellites really do for us? Where do we start? Weather satellites help meteorologists predict the weather or see what's happening at the moment. Earth observation satellites observe the planet for changes in everything from temperature to forestation to ice sheet coverage. How about GPS or global positioning systems? The goods we buy often reach distributors and retailers more efficiently and safely because trucking firms track the progress of their vehicles with GPS. Sometimes firms will even tell their drivers that they are driving too fast. Communications satellites allow for telephone and data conversations. Newspapers and magazines transmit their text and images to multiple printing sites via satellite to speed local distribution. Cable television depends on satellites to distribute its transmissions. Downed aircraft and distressed ships depend on satellite relay to get their signal to search and rescue teams. Navigational satellites help ships and planes navigate. Scientific satellites perform a variety of scientific missions. The Hubble Space Telescope is the most famous one, but there are many others looking at everything from sunspots to gamma rays. These are just a few of the many applications that satellites are used for today. Now, how do satellites get into orbit in the first place?
Back start. Copy, direct back start.
All satellites today get into orbit by riding on a rocket or by riding in the cargo bay of the space shuttle. After a rocket launches straight up, the rocket control mechanism uses the inertial guidance system to calculate necessary adjustments to the rocket's nozzles to tilt the rocket to the course described in the flight plan. This diagram of a cannon illustrates the need for maximum velocity in order to get the satellite into proper orbit. In most cases, the flight plan calls for the rocket to head east because Earth rotates to the east, giving the launch vehicle a free boost. The strength of this boost depends on the rotational velocity of Earth at the launch location. Once the rocket reaches extremely thin air, at about 120 miles up, the rocket's fuel cells will be jettisoned one by one.
Trend with -2. Nominal margin is only 7 foot per second from all we.
At the same time, the navigational system fires small rockets called attitude thrusters, just enough to turn the launch vehicle into a horizontal position. The satellite is then released.